So may I introduce the next moderator? It's Thomas Harrer, an IBM Distinguished Engineer, CTO, Server and Storage, IBM Technology, Technical Sales, EMEA, Germany. As a Chief Technology Officer, Thomas Harrer and his team deliver innovation with hybrid cloud and artificial intelligence, leveraging all types of data and evolving the technology to enable clients to address new digital business ideas. With a strong foundation in computer data science and extensive experience in IT infrastructure and technology, Thomas enjoys bringing different elements together to build the architecture of the future. He loves to discuss technology, trends, AI, data, blockchains, and architectures for mission-critical hybrid cloud solutions. I'm happy to have Thomas Harrer with us. Thank you.
Thank you very much, Detlef. And I'm very honored to be here, to stand here. I'm actually to stand here in front of you. I would be happy to stand physically in front of you, but this time, obviously, as we all know, this is not possible. But I'm looking forward to meet you in person and also to have these talks in the breaks or at the evenings that we all miss with one year and a couple of months of the pandemic. So thank you very much, Detlef, for introducing myself. That enables me to just start without introducing myself, but let me also welcome everybody or say hello to everybody out there. We are virtually connected, even if we are not physically connected. And I hope everybody is feeling good, is not so overwhelmed of these virtual events. Actually, I hope that you are safe in your place where you are, in your home office. I'm actually in my home studio, which is a home office with a very nice background there. And it feels like I'm standing here still, nothing moves. But when I think about movement, I know that we are, and you also, given on your latitude, you are moving because the Earth, the planet is moving. We are moving with 300 meters per second around the center of this planet. And also the planet is moving with 29.7 kilometers per second around our sun. And our sun, with us together, we are moving with 220 kilometers per second around the center of our galaxy, the Milky Way. And when I consider architecting the future, so the future of the movements of planets is quite predictable. We can calculate where we are in the next year, where the moon is, the sun, the planets, and how the constellations will work. What we cannot really predict is human affairs. So what you, what your companies, your organizations, your families, what will you do in the next year? Nobody knows that, but hopefully it's going a good direction. And this brings me to the first message here. And this is from William Shakespeare. When it comes to the future, he said, "It is not in the stars to hold our destiny, but in ourselves." And that means we can really architect the future. And architecting the future with IBM Technology probably is now the topic because IBM changed the go-to-market model. We combined all different units into one element. So everything that has to do with technology, from systems to public cloud to security to software, everything is now in a unified go-to-market, and that unit we are calling IBM Technology. But we always need to get everything into a historic perspective. And probably those who know me know that I'm always looking back very long times, looking back what technology did for humans is nothing that just started last year or in the last decade. It actually started many, many centuries before us. And probably what makes us unique as humans was the ability to use tools and to communicate and organize us in larger groups behind ideas. And this is not something that we invented in the last 300 years, but obviously we got a push when we invented the steam engine to help support our human and also the animal labor to do some crazy things, to move faster around or to produce goods without being dependent on human labor anymore. And it brought us to the moon, and it helped us to communicate in a much better way than all generations before us were able. And this is based on the computer. When I try to describe the history, a model which was shaped by a Russian economist, Nikolai Kondratiev. He was creating a theory about the big development cycles. And in his mind, these cycles have been 50 years or so, with some heights, some lows of development and of economic impact. And we can clearly explain the last couple of 100 years based on these cycles. So it probably started with a big push by technology in that industrial revolution back in the early 18th century. Then it went to another layer, to another level with the age of steel and railways in the mid of the 19th century. So we started to move around. But then electricity and chemistry added so much to that, because we were able to control what's going on in the world with electricity and build materials that have been never possible before. And then beginning of the 20th century, the next big cycle was the age of oil and automobiles that we saw helping people to get mobile and to get around, and also creating new materials and new basic stuff that helped to shape our world. But then in the middle of the century, probably in the 70s or even before that, in the 60s, a big new cycle was starting, which is the cycle of information and telecommunications, which so much shaped our world. Nothing that we used to have today, even this meeting, would be possible without that big cycle that we have been in. But the big question is, what will be the next big cycle? And I'm not quite sure, so I cannot predict the future very much, but I'm quite convinced that we will use technology to make something for the good, for our planet, for humans. And probably it's the age of health, of sustainability. There are so many problems of that planet, of resources. We need to come to a sustainable model, and technology will help us to hopefully get closer to that. We also know that technology is a problem by itself, but with that, we are entering a new age, hopefully. And this exponential growth in efficiency with technology, with especially IT, with computing, with storage, that helps us to hopefully get into that new age. And it will continue to change our world. So it will probably continue to help us to improve our health. What we are right now seeing is that massive trend to use data to cure diseases like the COVID-19 disease, where we have data to build the vaccines. And building a vaccine is a data science methodology these days, because you need to understand the RNA of a virus and the way how it works. And then you can design a vaccine probably as you design a software. And this leads us into precise precision medicine, coming from a large group of patients into a one-off group, so an individual treatment of a single person, because we understand the genome, we know how things are working, how the microbiome, the bacteria in your gut are contributing to health. And probably this will help us for this age of sustainability and health. But also education, entertainment will continue to evolve. We see that with homeschooling right now, that there are ways to attract young people and to help them to get educated or to get entertained using virtual technology. It will not stop there. We will see autonomous vehicles by leveraging very advanced AI. So cars will no longer be dependent on the driver or will not be dependent on a network. They can act fully autonomously and hopefully in a better way, more safe than humans can do that. And it will cover all aspects of life. It comes to money or to digital assets, as we say. A digital representation could change the way how we trade, how we exchange values, and the banking industry will be extended dramatically by especially having all the currencies extended by stable coins, by currencies that are regulated in addition to those non-regulated cryptocurrencies that we also see right now. It will continue in manufacturing, in sustainability, for energy, even in food production, where automation, AI, plays a really big role. And when we look into that, what drives that? Actually, it's efficiency gain, which brought us to a situation where we enjoyed exponential growth in data, because to create data, to store data is gaining efficiency. It means every 2 years you can have double the data at the same cost. And this means that it gets feasible to use data from more and more sources, not only in a central environment, in a data center created out of organizations which are not moving. It could be extended to machines, to drones, to sensors that are everywhere, moving in machines, in cars, in airplanes. And this kind of data, when it gets leveraged, is providing additional value. We have to see there are two kinds of data. There is the structured data, which is also growing exponentially, but not so fast, or is no longer the majority of data. And there is the unstructured data. Structured data, that's the information that makes the world go round. Everything that is stored in a database system that is created by a transaction, describing some value, some money, some contract, some information about a status of a business, that is the core critical data of this world. Without that data, nothing would work. And it's important to have that data as secure and consistent as possible to support most of the business processes of that world. But then there is this vast growing unstructured data that comes from cameras, from sensors, from the DNA, of course. So you see the picture of a DNA in the background. When it comes to that huge number, 165 zettabyte, it does not sound very huge, but it's probably difficult to comprehend. And I give you two analogies for that. The first is CDs. You remember in previous years, we used CDs to deliver music. So you could buy your favorite piece of music on a CD. CD is 750 megabytes of data, roughly 1.4 millimeters. And if you store that 165 zettabytes on CDs, it will be a staple reaching 290 million kilometers from here, from planet Earth to the sun and back again, nearly. A huge amount of data. But if you store the same data in DNA, so that information that is delivered from one generation to the next. So we humans, we typically have 3 billion of DNA bases, or the nucleotides as they are called, for different molecules: adenine, cytosine, guanine, and thymine. So information, 3 billion of these 4 different flavors, making 2 bits of these bases. 3 billion of that is also 750 megabyte, of course. So the whole genetic information from a human would fit into one CD. But if you store the 165 zettabyte in DNA, it's not very big. It's only 690 gram of materials to store all that information, which shows you that Mother Nature is very, very efficient. So data is the asset, and data really drives the innovation. Data is the basis for everything that we are doing. Is it an algorithm that we are building as humans, or is it something that is coming out of this high potential artificial intelligence area? So, and I would say besides data, there's the other aspect which is important, and that is actually the intelligence. So intelligence is not only what comes out of a AI training. This is an important part, but intelligence is also the intelligence of your developers who created the code for the core business processes to support the way how your company interacts with customers. And you also see that you not only create your intelligence by yourself, you leverage external intelligence. You get that from vendors, or, as Mihai already showed very well, from the open source world, from you leverage open innovation. So all the investments that others have done is open to you to integrate into your business. But then, especially if we think about the unstructured data or think about medicine, AI, artificial intelligence, becomes the major driver for innovation. And it's not one or the other, so having procedural intelligence or artificial intelligence, it's the combination of both. So a wise company will invest into integration of their own intelligence, the intelligence of the humans, with the intelligence coming from the AI, the artificial element. And it's no longer restricted to central ideas, it's going out at the edge. Probably those of you who have been in the presentation of Mark Fiamente yesterday have seen the importance of the edge. And this is because it's so affordable to act at the edge, to generate data, to leverage the data, to automate out there. And therefore, any kind of strategy for innovation should look into the edge, should look into intelligence, and should look into data. Probably you have heard that, but I want to repeat it. It's about the cloud platform. And a platform is something where you put some standards in, and then you can put other elements on top of it to create innovation and to modernize. And probably you all have already created your platforms and you use those platforms. And we as IBM, we have provided technologies for these platforms. And let me call them the mission critical systems, because these are the ones with the structured data that makes the world go round. And these are probably in many large banks sitting on a mainframe. The 90% of all the transactions in the world in the banking space are processed on mainframes. They could also be on a power system where we have the largest SAP systems, for example, running. And of course, all of these platforms will need some software, some middleware, some storage. So they are here and are still very important, because without them, nothing would work. But as Mihai already well explained, the world is going into a containerized mode for a new hybrid cloud and AI platform. So all the kind of new implementations are no longer monolithic. They are cloud native, using microservices, using a orchestration platform. And our vision here for the market is to innovate around an open ecosystem based on Red Hat with OpenShift, with the Open Hybrid Cloud Platform, and providing some intelligence into it from software that sits on top of it, from services that could be leveraged, which is not only limited to IBM, which is extended to the ecosystem, as we already heard. And ecosystem means that we want to integrate more and more partners into that. And not only the Red Hat marketplace, the open ecosystem, but also an ecosystem of commercial partners, of vendors who innovate based on that open hybrid cloud platform. We as IBM, we put most of our software in that containerized space and deliver it with OpenShift, with Red Hat OpenShift, and we package that in the last years as cloud packs. So you see where some kind of innovation is coming from. The value that we are providing is that you can develop your applications out of that platform and run it everywhere with consistency, with security, with consistent models between an on-premise data center, on the mainframe, on power, with storage, but also in different clouds, from IBM Cloud to Amazon, Microsoft, Google, at the edge, and also in the private cloud. And probably the first thing that I need to get you insightful here is that the platforms that I also want to bring into the center of my thinking here, because it's part of the topic for my presentation. So IBM C, Linux One, Power, and Storage, they are already in all of these different flavors. So we have mainframes in the IBM public cloud, delivering the most securable, we call it hyper-protect services, to store crypto keys and to manage databases or to manage digital asset platforms we call it confidential computing. So in a way where customers can keep their keys, so no need to share the encryption keys with IBM and be without not needing to trust anybody, having confidentiality and privacy on the data. This is very unique and something where our mainframe technology enhances the IBM cloud, especially when it comes to regulated industry like the financial services industry. But we also have the other technologies in different clouds. There is, for example, Power in the Google Cloud. There are storage offerings in Amazon and in Microsoft. Tapes obviously are used in many of these hyperscalers, and you can bring those into the edge or in private clouds as well. So the intelligence is now really coming from the ecosystem and from the platform. It's you innovate using intelligence that is already there. But intelligence is also coming from integration with the mission critical systems. So these mission critical systems, they are long-term. They are probably not moving fast, but they are critical and important. And adding innovation, bringing that close to the back end, to the really backbone of a company, that could help accelerate innovation a lot. And these architectural topics, these ideas to bring things together, these are major drivers that shows you how valuable a hybrid cloud strategy can be for you. And Mihai already showed you some numbers on that, but that's the exact idea behind it. And if you want to be compliant with regulations where you cannot put data in a public cloud, then a hybrid cloud is perfect, because you can decide having that in your own data center or with a partner, a local partner in your country, and be sure that no secret service is able to access the data. And looking a little bit closer into that platform ecosystem, you see there are already many partners in the IBM partner world. So many commercial partners delivering on that platform. And in the Red Hat marketplace, there are already dozens, hundreds of partners and options that can be leveraged in that OpenShift ecosystem. And OpenShift, as you know, is the best tested, enterprise-ready, secure, but still open, containerized orchestration platform based on Kubernetes in the market. There's nothing else that compares with OpenShift if you do not want to build it by yourself, as Mihai made with his analogy of the car. So that's probably OpenShift is the speed car, which is already tested and integrated and enterprise ready. So the other side of the coin of innovation is always the cyber threat. And I have a couple of numbers with you. 34%, that's the amount of internal threats, or the amount of cases where a cyber threat started internally. And this is not only because people have been bought with money. They could be tricked by some social engineering. And after the hackers have been made aware, or maybe friends, they just send a very special email which you would have expected because they have been announced, and then you click on the attachment and they are in. So then the other numbers, 3.86 million, that's the average damage a data leak or an incident has created in the last year, according to the latest Ponemon data breach report. The 7.13 million is the average for healthcare. So healthcare is affected bigger, but it's so the damage is higher. And we all saw that, especially the vaccine companies have been threatened by some cyber attacks in the last time, because their business is right now so flourishing and so good. The 8,000 million, that's the number, the damage that WannaCry had made back in 2017. And you probably remember that WannaCry ransomware was only active for a couple of days in May, until somebody found the target of that and just took that address out of the network. But still, with only a few days of activity, the damage was significant, 8 billion. The 60 million number, that's the highest fine a company had to pay to the European Union because of GDPR problems or data breaches that are relevant to GDPR. There have been higher fines announced, but because of COVID and the business situation, a famous airline was relieved, and they did not need to pay the more than 200 million that originally have been announced. But 60 million is still a very high number. And 280 days, that's the time that flows until a hacker has got into a company and this famous email occurs. Email says, we have encrypted all your data. You could get your data back if you put, let's say, 100,000 euros in Bitcoin, in a Bitcoin wallet. And if you do that, then probably you will anyhow not getting back your data. So, and that's probably the most shocking one, that it takes so long. And what are the hackers doing in that time? They are actually understanding the infrastructure, understanding who is admin, trying to get out the admin password for the backup administrator, and then destroying the backups before they start to encrypt the active data. And so when they did the active data, there is no way back unless you have an air gap and be able to have data which cannot be changed, even not by a backup administrator. So why I'm saying that, it's really the other side of innovation. So all the strategies have to be balanced, investing into cyber resiliency as well as into innovation. And a very good combination is using these IBM platforms that I'm now talking about. So on the mainframe side, mainframe is still the heart of the economy for many industries, because they are running 90 billion encrypted transactions per day running on mainframe technology. it's also the platform that provides the highest scalability for the new workloads, these containerized workloads of 2.4 million containers on a single system. And it's actually also good for the environment because it's reducing the data center footprint 4:1 and the power by 2:1. So without any zero code changes, a mainframe can fully encrypt container data at rest in flight, so this kind of confidential computing that we are talking about, and helps organizations to overcome the high cyber threat right now. And one area which is amazing is the area of digital assets. So consider currency, that's already some kind of a digital asset, but consider a physical thing like a ship or a picture of Rembrandt, for example. So maybe there is a business model to earn a part of a Rembrandt. So 100 people could share the ownership of a Rembrandt. And the right to have 1/100th of the Rembrandt could be described in a digital certificate. And this certificate, if you have it, you can sell it, you can trade it. It could grow in the value over time. Others could combine that. You could split it into different things. So it's about describing the rights that you own something. And these kind of scenarios, these are growing right now dramatically. So we expect that the market for digital assets is going into 100 billion in the next years to come. And many startups are investing into that area, and also traditional banks are going into that area. So, and with a Linux One system, we have two major differentiators that helps to avoid a data breach for these digital assets, because if those tokens get lost, then everything is lost. And one is the crypto service, the secure keys, securing the crypto keys with a FIPS 140.2 level 4 certified an element is more than any technology else in the market can provide today. And then having a secure enclaves, so an encrypted enclave where all the processing is done, where even the administrators only have access via some APIs and cannot see the data, cannot change the data, cannot manipulate anything. And we have a 2 eyes principle on that. So this combination, confidential computing with the secure keys and our secure DevOps pipeline to build the code for that, that is helping organizations to create the innovation around digital assets. And this can be done on premises with Linux One. And for example, startups or new companies like Phoenix Systems in Switzerland have decided to use that in their own premises. But it could also be used in the IBM cloud. And we just released a story about Metaco, also new company in that crypto valley in Switzerland that is using the IBM cloud, the HyperProtect services to do their digital assets. But when it comes to containerized innovation, we can also say that a mainframe could be very beneficial. So one US bank started an innovation project a couple of years ago. They decided for OpenShift, but they decided to use that on an Intel platform. But when it came to production, and you know, it does not make sense to have it as an island. You always need to integrate with the existing core backend banking system. And when it came to production, they realized it does not run very well because of the latencies when it comes from one platform to the other. And then they came to the idea, which was then technically possible, to implement OpenShift on the mainframe, co-locate it to the backend, where we still have COBOL applications in that case. And now with a 7 times better latency, lower latency, the application performance and the overall stability of that environment was much improved. So now the situation works very well together. And that shows you the strengths of hybrid cloud, where we can integrate on the same platform if that is needed, to leverage the critical data. So the next one is power systems. Power, that is also something where many companies have invested and put their critical core systems on. For power, we are providing some very interesting flexibility, and not only on premises when typically organizations are purchasing power systems. They can do that in a more traditional way, but they can also purchase a base model and then have some power capacity credits or some entitlements that could be added on the fly or could be just calculated and built on usage. And we also have Power Virtual Servers in the IBM Cloud, of course, where customers could even use an OpEx, operational expenditure model for their whole service. So they don't need to invest any money. They just pay for a monthly usage of that. And of course, we already have announced that there will be a mixture of these two models, a hybrid cloud credit model, where customers pay some credits to either use on-premise or use in the IBM Cloud. And that gives a big advantage for flexibility to use that capacity wisely. Power is the platform which enjoyed the biggest growth for HANA, SAP HANA, which is considered a critical system, especially when it comes to S4 HANA. And SAP encourage all the clients to move to S4 HANA in the next couple of years to come. And Power, with its RAS, reliability, availability, and serviceability, with its flexibility based on the hypervisor and its scalability and performance, is a platform where HANA runs very well. So, and with that, already 3,000 clients have decided to move to Power, and including those who started with x86 and decided to go to Power because of these elements, including SAP, by the way. So SAP in their SAP HANA Enterprise Cloud decided to use Power for the large HANA implementations. And it's also the most performant system out of the 10 most powerful SAP certified servers in the cloud. The IBM Power Systems Virtual Server take the top spot. And very good reference, not the newest one, but I know the chief architect of Co-op somehow and met him sometimes. And I like the story from Co-op because Co-op started with x86 for their HANA implementation, BW, of course. And when it came to an extension of the platform, after 3 years, the scale-out cluster with x86 servers was just no longer extendable because it needs some kind of homogeneous of technology, and the models have no longer been available. Co-op looked again into the market and found that a Power model with the consolidation and flexibility could be a very good option. And then they decided to use high-end powers and just realized that with only a quarter of the resources of the CPUs, they get 4 times better performance out of that infrastructure. So a 16-time improvement when it comes to efficiency. So very good, easy to remember case why HANA on Power is so beneficial. And there's another interesting case where it comes to the hybrid cloud modernization. In that case, a cloud pack for data for the mortgage approval process of that bank. And also that bank decided to use that on Power, so with a subset of functionality of the cloud pack for data, which works very well. And now they enjoy 50% faster mortgage approval times, reduce the data latency, and got a very good solution out of the cloud pack for data based on OpenShift on the Power Platform. Last but not least, I have to say that storage is still key. Storage is the basis for everything. Without data, and data has latency, of course, data has gravity, data is something that needs to be considered completely different than a stateless application. A stateful transactional application needs to be really considered using the right data infrastructure, having probably some mirroring into a remote data center, even in the cloud, because the cloud could also have some damage. And if you are on a server that is in a data center on fire or on water, then you probably also need to have some backup or some disaster recovery solution. So the IBM data portfolio has been extended very much this year with a new flash system, which is not yet on the slide, but it's getting you 8 times better density than the previous flash system. And this is called the flash system 5200. It's only half the size, and only a quarter of that makes the same performance as the previous flash system 5030. And this is because we use these flash core modules. Flash core means an AI is built into a module providing reliability and performance on flash modules that may be not so reliable by themselves, but with that AI and with some good tricks and some processing capabilities, the whole module gets enterprise class and the highest performance in the market. It could compress, it could encrypt. And so this flash system line of family, this family of products provide beneficial differentiation for any kind of storage. And when it comes to supporting OpenShift and containerized workloads, storage software and an offering called the IBM Storage Suite for Cloud Paks help to support new modern cloud native application developments with the right storage infrastructure, combining Red Hat storage with IBM storage. And of course, don't forget tapes. Tape is still the most efficient way to store data, short-term and long-term. And tape has a roadmap of innovation ahead of it, which outperforms everything else in the market right now. So no flash will be able to compete with tape on efficiency. So it's a wise decision to get tape into a IT strategy and store data on tape that is not accessed every day. So backups, archives, they are very good on tape. And because you see that quantum computer in the back, we already announced that our tapes are using quantum safe encryption for having a very long-term sustainable way to store the data. Even if quantum computers get powerful in the next 10 years to crack all the existing codes, the data on tape will be safe. One customer example for IBM storage is Continental. Continental, you know, is providing products and services to the automotive industry. It's one of the large supplier in that industry and obviously also engaged in the autonomous driving space. And autonomous driving means large amounts of data that are collected from the test cars out there that need to be tagged and need to be fed into training sessions to create an AI model to act autonomously. So these petabytes of data, even exabytes of data, need to be managed wisely and efficiently. And Spectrum Scale, the global file system from IBM, which was used to be the foundation for high performance computing or for media companies in the world, that is also a perfect solution for an NVIDIA-based training architecture for large AI models. So Continental decided to use Spectrum Scale and IBM Enterprise Storage, Elastic Storage Server, I think is the right name, ESS, for the AI training to deliver advanced functionality in the future cars. So I don't want to go into the quantum computer too deeply, but at the end, I just want to recap what already was presented yesterday. And this picture, probably you saw that already. It's Arvind Krishna, our CEO, and Dario Chil, our Senior Vice President and Director of IBM Research. And they sitting or Dario is sitting in front of the new cage for the next generations of quantum computers. And as you can see, it's huge because we expect that we can scale that technology by factors with a roadmap leading into thousands of qubits and even going beyond that towards 1 million qubits. So without going into the details here, I want to summarize. So while we cannot easily predict everything of the future, we can architect it. And a hybrid cloud platform, and you remember the platform is more than just a red thing, it's the whole picture, the whole idea to have that flexible, innovative platform to create intelligence, to leverage data. This platform enables innovation and competitive advantage more than any other strategy. Because you can leverage data very securely, you can integrate with existing application, become smart and modern, deploy it into the best cloud model with lots of flexibility, and have a better infrastructure with the biggest efficiency that you can create and architect right now. Thank you very much.